Hello, my name is Geetika Rohra, and the topic of my project is giving back to the coast. Humans, more specifically the greenhouse gas emissions we generate, are the leading cause of the Earth's rapidly changing climate. CO2 is the greenhouse gas most commonly produced by human activities. Climate change threatens coastal areas extensively. It is likely to alter patterns of wind and water circulation in the ocean environment. Such changes influence the availability of essential nutrients and oxygen to marine organisms, causing thermal stress that contributes to coral bleaching and infectious diseases. In California, population of purple sea urchins, which are kelp-eating species, have exploded, and more than 90% of bull kelp canopy along California's coast is gone. The goal of this experiment is to reduce CO2 emission that is caused due to the construction, and the aim was to collect materials off the coast and design something to give back to the coast to help the ecosystem. I collected algae and sand dollars. These materials are easily available around any coastal area. Algae has a slimy texture and can hold on to any surface. It has a pigment which allows for photosynthesis. This makes algae a source of energy. Sand dollars shells are made of calcium carbonate, which is used in the making of cement and would be helpful in reducing CO2 emission caused by extraction and burning of limestone, which is a source of calcium carbonate. Sand dollars are a relative of sea urchins and have similar shell properties. The shells of sea urchins are also made of calcium carbonate. There have been efforts to reduce purple sea urchins, which is happening through making it a dish on restaurant menus, but the use of the sea urchin shells is still a question. This experiment helps in using the shells of sea urchin. To start, I experimented with biocement by using different ingredients, for example, sand, gravel, algae, refined algae, and sand dollar. I noticed the cement is sticky. The second experiment was to make bioplastic. For the bioplastic, I used a similar technique where I added and mixed different ingredients. I used tea leaves and turmeric for texture and color. I realized with sand dollar the plastic does not set well, and so agar worked the best. The final experiment was to combine the first two experiments. I 3D printed with a syringe by mixing ingredients using in biocement and bioplastic. I tried using different quantities of ingredients to make a filament that sets at the right time. This was difficult with using a syringe, so eventually I used a PLA filament on a 3D printer to print a prototype. The PLA filament is kind of a bioplastic as it is made with cornstarch. Looking at the effects of climate change, I wanted to design something that helps in reducing the effect of construction and also gives back to the coast and its inhabitants who have been affected due to the negligence of humans. Therefore, I designed a seawall which is 3D printed and has a hard and soft materiality to it. The structure is made of biocement, which is rigid and hard, giving it stability. The inside layering of seawall is 3D printed with bioplastic, giving it a coral like effect, which is flexible and soft. This wall can be optimized as per the site requirements. It can be freestanding, attached, or leaning. Millions of dollars are being spent in California to build seawalls due to the sea level rise. This project does so by keeping in mind the environmental implications of it. The seawall has algae growing on it, which is food for most of these species. It also acts as a habitat for these animals. In conclusion, the sea offers its own debris, and the project uses these debris to offer something in return to the sea. Thank you.